In today's lesson, I will be going through, I'll be focusing on circles today. Okay, so I'm going to show you how you can, you can add or you can subtract to eventually solve for the area or parameter of some so-called composite figures or some very weird shapes looking to you. Okay, Ken? And also, lastly, I will end off the class with some rearranging technique to solve area and parameter questions also. Okay, so just do a quick recap on area of a circle. Okay, because this week's in my classroom lessons, I noticed that there are still a couple of students who are not familiar with the formula, and that is why they get the questions wrong. Okay, so let's take a look at this. Okay, first remember, I mentioned to you a way to remember the area of a circle. Okay, I'm not sure whether you will find this useful, but yeah, because I still have students to tell me that area is pi times diameter or pi times r, or pi times d, just not pi times r times r. Okay, so perhaps this is just one way to help you remember. Okay, apple pie really rotten. Your apple is your area, your pi is literally your pi there, your pi. Okay, and then times r really rotten. Okay, Ken? Then lastly, your circumference of a circle. Okay, I have not thought of a catchy name for this. So in the meantime, I just hope you can just remember pi times diameter. Okay, Ken? And of course, diameter is equivalent to 2 radius. Okay, your diameter is equals to 2 radius, 2 times radius. This is your radius. This is your radius if this is the center. Please take note, any point from the center that touches the arc is your radius, okay? So now, I picked 2 commonly tested shapes, okay, that I noticed over the years. And I feel that by knowing how to find these shapes, it will put you in an advantage during your actual exam when you sit for the paper, okay? So now, let me touch on the first work example on quadrant minus triangle, okay? And yeah, some schools call it the boomerang or even a leaf, half a leaf. Let me just extend the dotted line. Okay, it looks a little bit like a leaf, or the shaded. So if this is the leaf, the entire thing is the leaf. The shaded part, we call it half a leaf. Okay, I'll let you decide which name you prefer. Perhaps in my class, I'm going to stick with half a leaf. Okay, so there's a way, okay, a standard step to find the area of a half a leaf. Okay, the step would be to find the area of the quadrant minus away the area of the triangle, the area of the right angle triangle. Is this clear? What is the area of quadrant? Okay, that's something that you need to find. Minus area of the triangle. Remember, for triangle is a 90 degree, sorry, for a quadrant. For a quadrant, each of the quadrant is actually 90 degrees out of the full 360 degrees of a circle. So, how will you find area of a quadrant? Area, right? So just apply the formula. And of course, you need to know that it's radius here, the 7 centimeter. So it will be pi times radius times radius. A quadrant is what fraction of a circle? A quadrant is 1/4. Okay, and I use 22 out of 7, yeah, because the question states so. And what about the area of the triangle? The right angle triangle, half times the base 7 times the perpendicular height 7 as well. Okay, and you will get 38.5 minus 24.5, and we will get 14. And we will get 14 centimeters square for the area of the shaded part. Okay? 4 similar circles, okay, with diameter 14 centimeter, which overlap, okay? Please take note, any point from the center that touches the arc is your radius, okay? This is the diameter of the circle. So what is the radius of the circle? The radius of the circle would be the radius of the quadrant also in that sense, right? Correct? Okay. For those who are lost, look at this. From the center, So this is your diameter. Okay, this is the center. Okay, diameter. So if this is 14, if this whole thing is 14, what is this? 7, right? Okay, and this is definitely, look guys, one circle you have 4 quadrant, isn't it? Okay, yes, thank you, Jaden is correct, well done. Okay, okay. So the radius of, in this case, the radius of the quadrant, it's 7. Okay, can 7 for question 1, huh? Okay, so take note. Let me just erase first, and then, okay, ladies and gentlemen, what would this question mark be? It would be 7. Okay, because these are the radius of the quadrant. Okay, the diameter is 14. The radius is 7. Okay, when I say radius of the quadrant, I also maybe also mean that is the radius of the circle that the quadrant is in. Okay, Ken? All right, Ken. So in this case, how will I find area of 1/2 leaf? The formula as stated in the work example is the area of the quadrant. So the radius is pi times 7 times 7 because that is your radius. And then I times 1/4 because this is not one circle, 2 circles, but 1/4 of a circle. Thank you, JD, that's correct. Okay, area of a quadrant minus the area of the right angle triangle. Okay, which is here. Let me use a color to represent the right angle triangle. Okay, that would be 1/2 times the base 7 times the perpendicular height 7. Okay, okay, and this will be 14. So this half a leaf is 14. This is 14. So what is the area of one leaf? One leaf would be 28. Okay, or in short, this figure, the shaded part has 8 half leaves. So you have already found what is the area of 1/2 leaf. So to find 8, we get 14 times 8. And this is our answer. All right?